So Jason Klein is the Vice President of U.S. Strategy for Energy Transition with Shell. So he brings the corporate perspective to complement the NGO perspective that Andrew provided. So Jason, over to you. Welcome.
Thank you. So it's a pleasure to be here today in our nation's capital. I'm going to talk through a bit about what is Shell doing with carbon capture and storage, what does it mean to us, and where do we see it in our portfolio. But first I have to express a bit of jealousy that Andrew and other NGOs get to come up on stage and just go straight into their presentations and really hit you with hard-hitting action. But I work for a Royal Dutch Shell. So what I'm going to start with is to remind you that there's going to be forward-looking statements. These are not our business plans or forecasts. Don't buy or sell Royal Dutch Shell securities based on what you're going to hear today. So that's a good, exciting start. When we look at where we're going in the Paris Agreement, Shell's purpose is to power progress together by providing more and cleaner energy. And that's how we help support society's ambition under the Paris Agreement. How do we measure our progress? Well, we've set out a net carbon footprint ambition to reduce the net carbon footprint of the energy we sell, including Scope 3 emissions, by 20% by 2035 and by around 50% by 2050 in line with society. And we've set shorter-term targets to measure our executives' compensation to make sure that we're delivering year on year on that trajectory of net carbon footprint reductions. And how are we, as Shell, going to deliver on those ambitions? Because we have a huge oil and gas business. Well, the first thing we're going to do is look at our own operational efficiencies. How do we reduce the greenhouse gas intensity of our operations themselves, our Scope 1 emissions? How do we reduce the greenhouse gas intensity of the power and steam and other goods and services we procure in our Scope 2 emissions? So that's number one. Then we look at what is it that we're selling to our customers. We have to continue the shift to more natural gas in our portfolio. We're about 50% natural gas in our portfolio today. We also have to shift to more biofuels and help our customers with biofuels, whether that's sustainable aviation fuel, or that's corn-based ethanol, or second-generation ethanol, or hydrogenated vegetable oil. We have to help our customers with that journey. We're going to continue to grow our power business. We have to sell more clean electrons as a percentage of our total energy given to our consumers to help meet these ambitions. Electric mobility. Here in the US, we've acquired an EV charging company. We've acquired several in Europe, so there are now Shell gas stations around the world where you can you can charge your car or fill your car with gasoline. It's entirely up to you. We have both available. And we have to support consumers as they make that move to electric vehicles. And then we get to these last two buckets that are really, really important: CCS and nature-based solutions. In our Sky scenario, we lay out a technically plausible but challenging pathway to get to the goals of the Paris Agreement. And in that scenario, we show net zero emissions for the globe by 2070. And in that scenario, we have 10,000 CCS projects. That's not for Shell, that's for everybody. The entire world would need 10,000 CCS projects the size of Quest by 2070. That's the 10,000 that Andrew referred to. And we also need the natural sinks. We're going to have to end deforestation. We're going to have to start rebuilding forests. We're going to have to look at agricultural and farming practices and livestock practices to see how we can help use nature. And unfortunately, this isn't a kind of multiple choice or pick 3 out of 5 or a few. All of these things have to happen. Every single one of these. And none of them is easy. Each one of these is challenging. So we're going to spend today talking just about the challenges around CCS, although, hopefully we're going into liftoff here in 2020 and really kick it off. But that's one challenging piece of a huge complex puzzle to deliver on the goals of the Paris Agreement. And on nature-based solutions, I should also mention, we now, in parts of Europe, you can buy nature-based offsets at the pump at Shell gas stations. So if you buy V-Power in the Netherlands or the UK, we'll buy a nature-based offset for all the emissions that you've just purchased with that gasoline. And for the lower grades of gasoline, we offer our customers the opportunity to buy an offset for their Scope 3 emissions from that fuel, which is about 1 pence a litre in the UK. And we're pleasantly surprised that about 1 in 5 consumers right now in this trial are opting in to the nature-based offset, which is something we're really happy about, and was probably more than we were hoping in some respects. So, CCS. We are involved in a number of CCS projects around the world, most of them in collaboration with other people in this room, and I apologize if I miss out some names of some of our partners here. I'll talk a bit about Quest in a second, Quest in more detail, but Quest is in Alberta. It's kind of our flagship Shell-operated CCS project. It is capturing CO2 off the hydrogen unit, the hydrogen SMR unit for our Scotford upgrader, providing clean hydrogen to the upgrader, and capturing that CO2 and sequestering it in saline storage. And we capture about 1 million tons a year there at Quest. TCM is the technology center in Morgstad in Norway, where Total and Equinor and Shell are working on looking at how we reduce the cost of carbon capture, just on the capture side. What other technologies can we deploy to reduce that cost? Gorgon is now up and running. We are a partner in the Gorgon LNG project and the associated CCS project. Gorgon, when it's fully operational, will be the largest CO2 capture facility in the world, capturing 3.4 to 4 million tons a year. And it came online, I think, in September of last year, and is still coming on more and more. Pernis is one of our manufacturing complexes in the Netherlands, where we currently capture CO2 that we hope to bring into an industrial CO2 sequestration in the Port of Rotterdam with other players in the Port of Rotterdam and the port itself. Net Zero Teesside was announced on Friday. This was an OGCI-led project that is building a zero-carbon hub, industrial hub in Teesside in the UK. And the idea here is that you use the North Sea depleted fields and the geology we have in the North Sea, and through a partnership of a lot of the IOCs and government that OGCI helped bring together, we capture industrial CO2, and we make it easy for these industries in this industrial zone to give us their CO2 because they're not the experts in CO2 sequestration or capture. And we will also have, with our partners there, a combined cycle gas power plant with CCS on it so that we can support the growth of renewables by having some more demand response on the power side. So it's a really exciting project, and I think a model of how other industrial cities can come together and build coalitions to decarbonize big industrial sectors. The Northern Lights project is with Norway, Equinor, and Total, where we're building a different commercial model altogether of using depleted gas fields in the North Sea as a permanent repository for CO2. But in this project, rather than transporting CO2 by pipeline, we'll be liquefying the CO2 and delivering it by ship so that Norway becomes kind of an open access CO2 repository for anyone who might not have the geology or the other conditions locally to store their CO2 permanently. And finally, Boundary Dam is a coal-fired power plant in Saskatchewan that Shell provides our technology to. We're not an owner or participant in the project, but we license our CANSOLVE technology to that project, which is capturing quite a bit of CO2 in Canada. And I think the point for this slide is that so much of this is through coalitions with governments, coalitions with partners. And it's a theme that Andrew brought up, and I think it's a theme that's going to come up more and more today. It's hard to do these projects one-off on your own. You need partnerships with governments and with other sources of CO2, with people that own the reservoirs or governments that own the reservoirs to make these things work at scale. So talking a bit more about Quest. Quest was done in significant partnership with both the federal and the provincial government in Canada, in Alberta. And they provided not only fiscal support, which is necessary for just about any CCS project, but also clarity on the ownership of pore space and making sure we had the right to inject the CO2, and clarity on the liability regime. So we understood what our liability exposure was long-term for injecting the CO2 and providing us support for that. In exchange for that support and clarity, we've committed to make everything on Quest publicly available. So all of our engineering plans, all of our operational data, all of our lessons learned on Quest are publicly available to anyone so that everyone can learn from what went well and can learn from how we could do it better. And we provide annual reporting on all of that. So far, Quest is on track to capture about 5 million tons in total later this year. We announced 4 million tons last year, so you can expect 1 million tons a year. We're going to have a 5 million ton announcement sometime this year. We've had really good operational success, over 99% operational availability. It is currently, Quest has sequestered more CO2 than any onshore CCS project with dedicated storage, geologic storage. So we're very happy with the Quest project. But when we talk about CCS, there are skeptics out there. Not everyone's on board with CCS. Some people question whether this is a handout to oil and gas or whether it's truly effective. So we have to be really clear with society on what we're doing. So it's important that we can demonstrate the inventory of CO2 that we've been capturing and injecting. We have to demonstrate permanent containment within the reservoir. We have to demonstrate that the CO2 is staying where we expected it to stay. Every year in Quest, we make all this data publicly available. So we report to the government and to the public what our CO2 inventory was, projected versus actuals, what our containment data is, what all of our monitoring wells are showing. So we show not only how much we injected, but where we modeled the CO2 plume to go, where it's actually gone for our monitoring wells. And all of that is publicly available so that everyone in industry and the local community can understand how the project is performing. So what have we learned? Firstly, it's important to point out all these numbers are in Canadian dollars. So I'll try to translate in a bit. But the good news is the project has come in under budget and on time and has exceeded our expectations in many ways. We originally estimated, taking all in feasibility, CapEx, OpEx, everything, 120 Canadian dollars a ton. We've delivered it at about $80 a ton all in. Our OpEx continues to go down through lessons learned, all of which are publicly available. And we believe today that if we were to rebuild Quest, and I want to be cautious here, no two projects are the same. It depends on the volume of CO2, the concentration of CO2, proximity to reservoir, what kind of reservoir you've got, what legal and liability regime you have. But if we were to redo Quest today, we believe we could deliver it all in at under 60 Canadian dollars a ton, which importantly is less than 50 US dollars a ton. And that's a pretty important number here in the US when we talk about 45Q, which provides $50 a ton. So what we're saying is we think if we were to do Quest in the US with the same legal regime and everything else, and the same technical issues, we could deliver Quest at under $50 a ton. And all of that information is publicly available. Okay, so the last slide I want to touch on is just to say we have to, as an industry, continue to drive down costs. We have our CANSOLVE technology that we use as an amine for CO2 purifying, but we are looking at solid sorbent technology. This is a particular demonstration pilot in Vienna with local university where we're demonstrating a solid solvent that should reduce the cost per ton. It's a very small pilot, but we have to do these things to figure out what the next generation of cost reduction is. And by collaborating with universities and with our partners, we can deliver cost reductions, which are so important for us to get to that 10,000 Quest-sized projects by 2070. And with that, I'm excited to hand it back and we'll have a conversation.